For the last 2 years, working with an AI coding agent meant one thing. You type a prompt, it answers, you read it, you type the next one. Over and over. You were the loop. But in June 2026, a quiet idea flipped that completely. Boris Cherny, who leads Claude code at Anthropic, put it bluntly. He doesn't prompt the model by hand anymore. He builds loops that do the prompting for him. That shift has a name now, loop engineering, and it might be the most important skill in AI development right now. Let's break it down. Here's the core idea in one sentence. Loop engineering is when you stop prompting the agent and start designing the system that prompts it for you. Instead of typing the next instruction after every response, you set up a loop that runs on a schedule, against a goal. It finds the work, it hands it to the agent, it checks the result, it writes down what's done, and it decides what to do next, all without you in the seat for every turn. You define the goal once, the loop does the poking. To really get loop engineering, you have to see the staircase it sits on top of. Step 1 was prompt engineering, getting good at phrasing a single instruction. Then context engineering, realizing the magic wasn't just the prompt, it was everything around it. The docs, the history, the tool definitions you put in the window. Then harness engineering, building the whole system that runs one agent well. And now, loop engineering, the system that runs that harness again and again on a schedule until a goal is met. At every step, the leverage moves further from the raw model. But none of the lower steps disappear. A loop is still built out of prompts and context. A bad prompt inside a loop isn't fixed, it just fails faster on repeat. Prompt engineering isn't dead, it's table stakes. Now an important distinction, because agents already loop. Every time a coding agent runs, it does a little internal cycle. It reasons about what to do, takes an action like running a test, observes what happened and reasons again. Reason, act, observe, the famous react pattern. That's the inner loop. Loop engineering lives one floor above that. You're not steering each turn by hand. You're building the outer loop, the one that wakes on a schedule, launches the agent, checks its work, saves the state, and starts the next cycle. Inner loop, the agent thinks. Outer loop, you design the machine that runs it on repeat. Before this even had a name, there was Ralph. In 2025, engineer Geoffrey Huntley described something almost absurdly simple. Run a coding agent inside a plane while loop. Feed it the same prompt against a written spec. Let it pick one task, do it, test it, commit it, then throw that agent away and start a fresh one with the identical prompt. Repeat until everything's done. He named it after Ralph Wiggum because it looks way too dumb to work, but it works shockingly well. Here's why. A long AI session slowly rots. The context window fills with old reasoning and dead ends, and the agent gets sloppier. Ralph dodges that. Every pass is a brand new agent with a clean context that just reads the current state from a file. The intelligence doesn't live in one heroic run. It lives in clear specs, verifiable outcomes, and an external memory the model can't pollute. Loop engineering is basically Ralph, productized, and moved inside the tools. So what's actually inside a real loop? 5 pieces plus 1. 1. Automations. The heartbeat, a scheduled trigger that wakes the loop and finds work without you asking, say every weekday morning. 2. Worktrees. When you run several agents at once, this keeps them in separate, isolated copies of the code, so they don't overwrite each other. 3. Skills. Your project's knowledge, written down once, your conventions, your build steps, so the agent stops guessing the same things every session. 4. Connectors. Built on MCP, the Model Context Protocol, they plug the agent into your real tools. Your issue tracker, your database, Slack, a staging API. 5. Subagents. The big one, you split the agent that writes the code from a separate agent that checks it, because the model that wrote the code is way too generous grading its own homework. And the plus one that makes it all hold together, memory. A simple file on disk, anything outside the conversation. The model forgets everything between runs, so the state lives on disk, not in its head. The agent forgets, the repo remembers. But here's the part everyone underestimates. How does the loop know when it's done? If you tell it make the checkout flow better, it has nothing to grade itself against, so it just stops whenever it feels like it. The fix is to write the goal like a contract, not a wish. Spell out 4 things: the end state you want, the evidence that proves it, like the tests pass and coverage hits 90%, the constraints it must not violate, and a hard budget so it can't run forever burning money. And the smartest loops use that maker-checker split right here. A separate model decides whether the goal is truly met. The agent that did the work doesn't get to declare its own victory. So why does this matter? Because a well-designed loop multiplies a good engineer. Instead of one task at a time, you're directing several self-running cycles at once. A genuine step change in how much one person can ship. But a loop doesn't delete you from the job. 3 problems actually get sharper as the loop gets better. 1. Verification is still your job. A loop running unattended is also a loop making mistakes unattended. Done is a claim, not a proof. 2. Comprehension debt. The faster it ships code you didn't write, the bigger the gap between what's in your repo and what you actually understand. 3. Cognitive surrender, the temptation to stop having an opinion and just accept whatever comes out. Designing the loop is the cure when you do it with judgment, and the trap when you do it to avoid thinking. Same action, opposite outcome. The loop can't tell the difference. You can. So that's loop engineering. You stop prompting the agent and start designing the system that prompts it, on a schedule, against a goal, until the work is verifiably done. It's the next layer of the craft. But the rule underneath stays the same. Build the loop like someone who intends to stay the engineer, not just the person who presses go. Subscribe so you catch the next one, and tell me in the comments, what's the first repetitive task you'd hand to a loop?